Hey Dikers, so we are on journal 14 here, and I want to start out with this bell work by doing some problems from packet 3, so the white packet on page 2. So on page 2, there's this problem where it says, is this coordinate the solution to the following system of equation? And you're given a systems of equation, or in other words, it is a 2 by 2. In other words, it's two equations with two variables inside. So in class, if you were in class, I let you guys pick problems from this page. But we're going to do this problem together since we are technically not in class anymore. So if I were to figure out if this coordinate is a solution, isn't this my x and my y, right? And if I want to figure out if that's my solution, well, if I have two equations, and they have x's and y's in them, well, I'm just going to plug in my x, plug in my y, and see if I do get the number that's on the right-hand side. So when I plug in x and y, do I actually get 11? When I plug in x and y in the second one, do I actually get negative 18? So we're going to see if that really happens. So I'm going to start off with the first equation here and plug in my x and y value. So if I plug in my x value, that's negative 4 minus 7 times 11. And I want to know if this really does equal, so I'll put a little question mark above the equal sign. Does it really equal negative 11? So let's work this out. So if I multiply 7 with 11, isn't that negative 77? And then I bring down the negative 4. Well, negative 4 minus 77 is negative 81. And negative 81 is nowhere close to negative 11. So this is no good. These negative 11 does not equal negative 81. So because this is not true, this is not a solution. Meaning this coordinate here that they gave us, the x and y coordinate, is not a solution. Let's say that number 1, you plugged it in and it did give you the same value. Then what you would have to do is keep going. So you'd go to the second one, plug it in, and if that was a value, if that was a valid that it did give you negative 18, then you can say it's a solution. So in order for it to be a solution, it has to work for both equations or all of the equation. If one fails, the entire system is not a solution. So now that we're warmed up here, let's talk about today's method that we're going to learn. So we've learned substitution, we've learned graphing, we are going to learn something called elimination today. So elimination is one of my favorite ways of solving systems of equations because it kind of goes back to the idea of like your adding and multiplication skills that you learned long before you got into algebra. So let me just talk a little bit about what elimination and how you use this method. So you want to first make sure that the x and y's are lined up. So when x's and y's are lined up, typically you'll have your x's and y's on one side when you do this. And so elimination is great for standard form. So when it's in standard form, this is the best time to use elimination. And I'll show you guys what I mean when I show you guys these problems. So what you want to do is make sure the x and y's line up when you have two equations. You're going to choose one of the variables you want to cancel out. And to cancel out a variable, you need to be the same coefficient but opposite signs. So let's just take a moment to understand what that means. Same coefficients. So same coefficients like two variables like 3x and another 3x. These are two of the same coefficients, but it says opposite signs. So let's make the first one positive and then this second one here a negative. Well, when I add these two, because elimination, what you're doing here is you're adding both of the equation together. Well, if one of the variable has the same coefficient but opposite signs, when you add them, well, they're going to cancel out, right? Because 3 plus negative 3 is going to be 0. So they cancel out and just give you 0. So that's why we want to make sure that they are the same coefficient but opposite signs. So I'm going to do a few examples here to help us see that. So let's turn to the next slide. Okay, so notice how we're given a systems of equation here, meaning that, let me see if I can move this over. There we go. So notice that I have two equations here. And we call this a 2 by 2 again because there are two equations, two variables inside. And so if I want to use elimination, I want to see which variable do I want to cancel. But remember, in order to cancel a variable, they must be opposite signs and the same coefficient. So in this case here, out of the y or the x's, so which one, x or y, are they the opposite signs and the same coefficient? Well, you guys would probably choose the x's, right? They're already both 2's and they're already opposite sign. So you know what? If I were to stack them, notice how both of these equations are in standard form so that the y's and x's line up nicely? And so that was our first step, that we had to line up our x's and y's. Step 2 was to choose a variable you wanted to cancel. Well, the variables that are nice to cancel here are the x's because they're already opposite signs and the same coefficient. So they're going to cancel when you add the two equations. So notice I have a plus sign here because now I'm going to add vertically. So I'm going to combine like terms, but I'm going to do it vertically. So 3y plus 5y gives me 8y. And then the x's cancel, so now I'm just going to bring down an equal sign. And so 6 plus 10 gives me 16. And so if I'm trying to get this y by itself, notice how like now I just have y's to deal with. Because I eliminate the x's, I just have y's. So if I were to get this y by itself, all I got to do is divide by 8. That cancels. So y is equal to 16 divided by 8 is 2. And so now I have y, all I got to do is find the x. So if I'm looking for what x is, we go back to our, what we did when we had substitution. We just take our y value and plug it into one of these equations. So I'm going to just choose the first equation. It doesn't matter which equation you choose. So if I decide to plug this into the, sorry, that's a weird arrow. If I decide to plug this into the first equation, I have 3y, but instead of y, I'm going to plug in my 2. Plus 2x equals 6. If I'm working this out, 3 times 2 gives me 6. 2x equals 6. If I subtract by 6, that cancels. So I have now 2x equals 0. And to get this x by itself, I just have to divide by 2. And so x is equal to 0 divided by 2 is 0. All right, so I have my y, I have my x. If I were to write this as a coordinate, you guys would probably say, well, you would have your x first, which is 0, and your y is 2. So we have one coordinate here, so one solution. These two equations, when graphed as a line, intersect at 0, 2. And there we have it. We don't have to use graphing. We don't have to use substitution. Today, we are learning something called elimination. Let's practice this some more, but I want us to turn to the packet for a moment and do a problem from the packet, and then we'll come back and do some more examples. All right, so this one is on packet 3, page 3, so I want you to turn to that page, and I believe that this problem is problem number 2, so I probably should put that here. This is problem number 2 that I'm working on. And you'll notice that this time around, I have two equations. So let me go ahead and number them so that way you know which one I'm talking about. So this is going to be 1, this one's going to be 2. And notice how this time around, the w's or the z's don't have the same coefficients, right? This is 6 and 3, that's 8 and 6. So they're not going to cancel out right away. Instead, what we have to do is force them to be the same coefficient. And what we can do to do that is to multiply by a number. So what I notice is, well, if I take a look at the w's here, they are already opposite in sign, so that's kind of nice. But then I have to think about, okay, what number can 6 and 3 both be? So remember, we're using multiplication here to manipulate the numbers. And so in this case, I noticed that 3 can be a 6 if I multiply it by 2. Okay? And so all I have to do is make sure that the coefficients are the same. And I just decided to use W. I could have decided to use Z and try to figure out what number can 8 and 6 both be. Well, 8 and 6 can both be 24, but then I would have to multiply the top by 3 and the bottom by 4. You see how that's more work for me? Whereas this one here, I just have to multiply the bottom to make that the same coefficient as the top. So I'm just gonna try to cancel out the W's in this case to make this easier. So remember, we're adding these two equations, but what we're going to do first is the first equation here. Notice how I didn't need to multiply anything? So I'm just going to bring it down the way it is because I don't need to multiply. I want that coefficient to be the same. Whereas the bottom one, I have to multiply by 2 to make this 3W into a 6, right? But when you multiply, you have to multiply everything. Every term in that equation will get multiplied by 3. Sorry, not 3, by 2. So keep that in mind or else you will mess up. So if I multiply by 2, you get 6W, positive 6W. 2 times 6 gives me 12Z. Positive 12Z, and then 2 times 36, well, that's going to give me 72. Oh, sorry, my phone went off for a little bit. Okay, so back to this problem. So I am, now that I've multiplied that all the way through to every coefficient, I'm going to now add these two equations. So if I do that, notice how the 6 are already opposite signs and they're both 6s. So they cancel, so I don't have to worry about W's anymore. Instead, I can add the Z, so negative 8 plus 12Z is going to be, 4Z? 4Z. And then we have negative 44 added with 72. If you do that, so let's see. 72 with 44 is going to be 28. So now that I have all my like terms combined, I'm now going to divide by 4. And so there we go. And so Z is equal to 28 divided by 4, which is 7. So now that I have Z, I can plug it into one of these equations to get my W, right? So I'm just going to pick the first equation here. It doesn't, well, actually, you know what? I don't want to pick the first equation. That's a lot of negative signs. Maybe let's pick the second equation here. Why not? Since it doesn't matter. So our second equation here was 3W plus 6Z equals 36. So that was our original equation. So if I plug this in, this is going to be 3W, because I don't know what W is. Z is 7. And so I have 3 times W. 6 times 7 is 42. Equals 36. Well, if I want to get rid of this 42, I would subtract by 42. That cancel. 3W comes down. Okay, 36 subtracted by 42 is going to be 6. So if I divide by 3, W is going to be 6 divided by 3, which is 2. So in that case, if I were to write this as a coordinate here, shrink this a little bit. If I were to write this as a coordinate, which one comes first, W or Z? Well, I hope you know your alphabet because W comes first. So it's always like, go by the order of your alphabet. W's first, then Z. And so in this case, if you write this as a coordinate, you might see it as 2, 7. And this is one solution because you only see one coordinate. And there we have it. We have our solution. Let's do a couple of more examples, and I'm going to show you some really weird cases that might happen when you do elimination. So we'll talk about those two cases. All right, so these problems here, I'm going to go ahead and label them. I'm going to use elimination here, but first I got to pick a variable that I want to cancel, right? So when I'm looking at these two variables here, should I choose the x, should I choose the y to cancel? I'm not sure. But one of the things I do know, in order for things to cancel, they have to be opposite signs and the same coefficient. Well, in this case, I guess none of them are opposite signs. These are both negative, these are both positive. And they're not the same coefficient, so I really don't think it matters which one I decide to choose. So I might just decide to choose to cancel out the y's. You know what? Yeah, there we go. We'll decide to cancel out the y's today. So if I do that, I need to multiply the top by, well, a negative number to make it a positive, right? Because they're both negative. So I have to multiply by a negative number. And 3 can become a 6 if I multiply by 2. We just saw that, earlier. So I'm going to multiply by negative 2. And so if I do that, I have to multiply that with every term inside. So now my first equation is really negative 12x plus 6y, because, negative 2 times negative 3 gives you positive y. And then negative 2 times 5 is negative 10. And so now the bottom equation stays the same. I didn't have to multiply that. My y should cancel. And so I'm going to go ahead and add the two equations here. But wait a minute. Negative 12 added with 12x. That cancels, but I didn't really want the x's to cancel. My y's definitely cancel. Hold up. So if everything cancel, I just have 0 on this side? Okay, bring down that equal sign. So now on this side here, negative 10 added with negative 10. Okay, well that's a number. That's negative 20. But last time I checked, my math teacher told me that 0 does not equal negative 20, right? That's complete nonsense. These don't equal each other. So here's the thing. When you work this out and you notice that things start to cancel, right? Everything starts to cancel, and then this side is a number and that side's a number, and they don't equal each other, and this is complete nonsense. Well, then what you have here in this case is no solution. We can never have 0 equaling negative 20, so this can never happen. So if it's no solution, what do you know about the two equations here if you were to graph them? Well, we learned if something is no solution, they are parallel lines, right? Parallel lines never intersect. Never intersect. So that means that if they never intersect, they're never going to have a solution, because intersections are about solutions. The solutions are about intersections. And so in this case, you also know that they are parallel. Parallel lines. Okay, so let's do one more problem that's also kind of freaky like this, and we'll talk about what we would do in that scenario. Okay, so looking at this problem here, I have two equations, and again, I notice that their coefficients are not the same. All right, well, at least they're opposite signs, right? So maybe I'll choose the 2 and the 5, right? Because 2 and 5 can both be 10. So this time around, I have to multiply both of the equation by a number to make it 10. So what I've done is I've decided that I'm going to make both the coefficients be 10. Well, now I need to be strategic here. So I'm adding these two equations eventually. So if I want the top equation to be a 10, I have to multiply by 5, right? 2 times 5 gives me 10, and then I have to multiply everything by 5. Whereas the bottom equation, I have to multiply by 2 to get negative 10. So what I'm going to do is multiply the first equation through with the 5, so that'd be 10x plus 5 times 8, which is 40y. 5 times 6 is 30. And then our second equation here, if I multiply by 2, that's negative 10 in the bottom. 2 times negative 20 is negative, 40? Wait a minute. 2 times negative 15 is negative 30. Hold up. Do you notice what I notice? That this time around, not only the x's cancel out, not only the y's cancel out, but the constants cancel out. Like that's a positive 30 added with a negative 30. Everything cancels out. So that means I have 0 on the left-hand side and 0 on the right-hand side. Well, we do know that 0 does equal 0, so this does make sense. So we can't say this is no solution. Instead, here's the thing we have to think about. Because everything canceled out, that's telling me that these two equations here had to have been the exact same equation if everything canceled out, right? So if they're the same equations or the same lines, isn't that infinitely many solutions? Because if they're the same lines, that means they intersect everywhere. And if they intersect everywhere, you have infinitely many solutions. So anytime you notice when everything cancel out and you get just a number, but the other side cancel out and you get a number that's the same number, well, if they equal each other, then you have infinitely many solutions. So let's wrap up what we've learned so far. We've learned so many different types of solutions with this elimination scenario. So let's kind of summarize this. All right, so the different types of solutions that we encounter was the first one was one solution where you found an x value, you found a y value. So like the ones that we found earlier, right, were, I think I found, so using an example that I'll write here, we found one of the solution to be 0, 2. I think that was like the first example we did. And so we just got like an x value and a y value here. So that's what I mean by one solution. The x value here is 0. The y value here is 2. You have a pair, one solution, one coordinate. Whereas no solution is when you have, some number, let's call A, but then you have a totally different number called B. And, well, two numbers that are different can't equal each other. So that means that, well, this would be no solution because it's complete nonsense, right? That example is when we saw in example 2 where we had 0 equaling negative 20, but that can't be true. So that's why that was no solution. Whereas our next one here, our last one, is when we got two values that were the same. So they do equal each other, so everything canceled out, and then in the end, you had both sides of the equal sign being the same number. They do equal each other, so that was like that case when we saw 0 equaling 0. You could also have like a case where it was like 7 equaling 7. As long as both of the numbers are the same, that's just telling you that there are infinitely many solutions. All right, guys, that's it for this journal. So I hope that helps you out a little bit with the homework packet and gives you a better idea how to do these problems. All right, until next time, bye.